So in today's session, we will discuss about this deep learning for text and image processing. So let's start it. So what is basically this deep learning? So it is a subfield of machine learning using artificial neural networks with multiple layers to extract complex features from the data inspired by the human brain structures and function. So in this deep learning, we try to mimic the working of this human brain, okay, using the different layers. So if I want to give you the brief introduction about these layers in a deep learning, it has three layers: input layer, hidden layer, and output layer. So this input layer takes input from the data, and it processes that input in a hidden layer, and it gives us the output. Now the question is why there is a need of this deep learning, though we are having the machine learning. So the first key feature is superior performance. So it achieves state of the art results in a various tasks. So if we are having any complex task, it gives us the very good performance. Then automatic feature learning. So it learns complex features directly from the raw data, eliminating manual feature engineering. So in a traditional machine learning, we have to select the features or we have to extract the features. So there are different ways we can do that. But in deep learning, these models can automatically learn from the raw data, and it gives the importance of the important features. Then it handles the high dimensional data. So it effectively processes complex data like images, text, and audio. Now let's talk about how this deep learning works in a text processing or the natural language processing. So what is NLP or the natural language processing? It empowers the machines to understand, interpret, and generate a human language. Now, what are the tasks we perform in this NLP? So, the very first one is a text classification. So, in this text classification, we can do the sentiment analysis. So, sentiment can be positive or negative. Then, spam detection, whether the email is spam or a ham email. Then, topic categorization. So, basically, we can do the classification task in this text classification. Then, the second task is a machine translation. So, we can translate a text between the language. Let's say if I want to translate the English text into the German, so we can do it using this machine translation. Then text summarization, so condensing long documents into the summary. So if we are having the paragraph, so what we can do, we can summarize that paragraph into few sentences. Then question answering, so answering questions based on a given text. So chatbot is the example of this question answering. And then name entity recognition, so it's identifying and classifying the named entity. So let's say if I'm having any sentence, so my machine can understand, let's say Rahul is playing is my sentence. So here Rahul is a person. So my machine learning model or this NER can identify the Rahul as a person. Okay. What are the deep learning models for NLP? So the very basic model or the base model is a recurrent neural network. So it processes the sequential data like text, capturing context and dependency. But there is a problem of vanishing gradient. Then we are having a LSTM long short-term memory, which addresses the vanishing gradient problem and enables the better handling of a long sequence. Then we are having this gated recurrent unique GRU. It is a simplified and often more efficient alternative to LSTM. Then there is a transformer, which is a revolutionized NLP with attention mechanism, enable parallel processing and capturing long range dependency. Then BERT stands for bidirectional encoder representation from transformer. So basically this transformer is a combination of encoder and decoder. So this BERT is inspired from the encoder part of the transformation. So it is a powerful pre-trained model for various NLP tasks. Then we are having this GPT generative pre-trained transformer, which is focuses on the text generation. And then we are having this transformer XL, which is a improved handling of very long text. So these are the some of the applications of this NLP. Now let's discuss about the another aspect of deep learning called computer vision. So, what are the tasks we can perform under this computer vision? So, the very first one is the image classification. So, identifying the main objects or the category in an image. So, let's say cat versus dog. So, we can train the model with the lots of images of cats and dog, and my model should identify or classify the image in a respective classes. Then, object detection, locating and classifying multiple objects within an image. Okay, then image segmentation. So pixel level classification, dividing an image into regions corresponding to different objects or a part. So based on the pixel intensity, we can do this image segmentation. Then image generation. So it creates a new image from the scratch or modifying existing ones. The last one is the image captioning. So generating a textual representation or the description of the image in this computer vision. Now let's discuss what are the computer vision models we use for the specific task. So the very first or base model is convolutional neural network. So, or we call this as a CNNs. So it is a specialized for image processing using convolution layer to extract the spatial hierarchies from of the features. So using the filter and the convolution operation, we do capture the important features from the image in this CNN. Then AlexNet, VGG, ResNet, Inception, EfficientNet, these are the landmark CNN architectures with the increasing complexity and performance. So basically these models are trained on a huge amount of data, and that's why they are very efficient in terms of performance. Then generative adversarial networks. So GAN, it is the two networks, or it is a composite of two networks, generator and discriminator, competing to generate the realistic image. So generator can generate the fake image, and discriminator, the task of the discriminator is to detect whether the image is real image or the fake image. Then autoencoders, it learns complex representations of images, useful for dimensionality reduction and image denoising. And that's it about this deep learning of text and image processing. Thank you so much.